Hello, my name is Franck Walpole and I head the Technical Support Department at Concurrent Technologies. You probably know that Concurrent Technologies design single-board computers based on Intel processor. So we have SBCs, I'm going to say SBCs for single-board computers. So we have SBCs with the form factor of 3U6UBPX, AMC, VME, Compact PCI, and many others. And these products are used in many different types of applications. But today, I don't want to specifically focus on the hardware. I want to tell you more about some of the software technologies that we have either embedded in the product or that we provide separately. And one of these software technologies is called Secure Boot. So that is today's focus of this video. So when it comes to Secure Boot, I want to tell you a little bit more about what it is, how it comes about, and so that you have an idea if this is something you want to use in your application. So I'll briefly start with a little bit of history about the x86 architecture. The x86 architecture has been very popular for a number of reasons. First of all, at home, thanks to the PC market, this is a technology that has evolved over the year, but it's also been very popular in the embedded market because it's a very versatile architecture. And this has been the case thanks to a number of reasons. One of them is thanks to the BIOS. The BIOS is a key part of the x86 architecture. The BIOS is a piece of firmware that is used to initialize the computer in a standard manner. And that has proven to be very good because it allows, for example, operating system vendor to run on different type of machine based on x86 architecture without having to worry about the hardware. And this is why even in the embedded market, because you can run all sorts of different operating systems, you can run Windows if you want to run the same as what you have at home. You can run Linux if you want to take control of everything, but also you can run real-time operating systems like VxWorks, UNX, and so on. And even if you have server-type application, you can run things like VMware. So there's a lot of things you can do. Now, one of the things that the BIOS didn't take into account and doesn't do very well, doesn't do well at all, is take some of the security aspect, because nowadays the way we use product has changed. Many of the products that are used in the field are actually networked. They are connected to the internet so that you can leave them doing what they have to do and then retrieve the information remotely via the network. Now, when you do that, one of the things you need to worry about is anybody going to tamper with my system, with potentially the operating system I've installed with my application, or even just prevent the system from running in the first place. So you need to ensure this doesn't happen. Because there has been cases where people have been really worried about some of the virus that have been potentially installed even in the BIOS. So there was a real need to prevent this sort of things from happening. So a number of companies have worked, for example, Intel, Microsoft, have worked on, in the case of x86 architecture, on what could be an alternative to the BIOS. So one such alternative is UEFI. So UEFI does the same as the BIOS. It does it better because the technology moved on, you have bigger drive, you have the need to boot quicker, but more importantly, you have the need to ensure no one will tamper with the BIOS but more importantly, no one will tamper with what the BIOS is then starting in terms of operating system and so on. So this is possible thanks to the cryptographic signature. The way it's going to work is if you have the ability to add a signature to the code, for example, to the EFI code you want to start on the machine, and you can verify that the signature is the one expected, and only run it if you have checked and proven that this is the correct piece of code, then you'll know for sure that no one will be able to tamper with this. But it all starts with the hardware itself having the ability to check and make sure that the first piece of code that is run, i.e. a little bit of EFI code, has not been tampered with. So companies like Intel have come up with some technology called bootguard, where in their hardware, in the chipset itself, there is the ability to fuse information about the certificate signature used to sign the UEFI BIOS. So this is what we do at Concurrent Technology. Before we ship any product, we sign our BIOS, and that gets fused onto the board, such that if anybody tries to install a different BIOS to the one we provide, the machine won't even start. So this is what this is showing, where the piece of code from the flash is automatically downloaded, stored in memory, checked by the processor, and if the signature is not the right one, it won't run. And then in turn, once this first part of the UEFI code run, it then does the same for additional components. So for example, it checks the various EFI driver that are used in the system. But the same thing is done for BIOS extensions for additional device that you may have. And ultimately, the process repeats itself with the boot manager and the bootloader. And all this use a certificate to work. So you may ask, how does this work? Does it mean that to install an operating system in the first place, you have to first find certificate key, install the key on the machine for everything to work if you enable secure boot? Now, that is not the case. And that is because one of the things we do, and all BIOS vendors do when they ship a UEFI BIOS, that's called secure boot, is we leave in there the certificate from Microsoft. That's the reason why, even if you use and enable secure boot, you can always install, for example, Windows. So that's one of the mechanisms used. Because the Microsoft key is already in there, you can then boot additional operating systems. So the way this works is, for example, if I take the example of Red Hat, the first stage bootloader of Red Hat is actually signed by Microsoft. In turn, in this first bootloader, Red Hat can start a second stage which have their own certificate UEFI information, so that in turn, once we start, this can start Grub or Grub2, which itself has been signed by Red Hat, and so on, where the next stage bootloader can then load and check the signature of the kernel, and then check the signature of the device driver, such that you end up with a system that is the one you expect, that has not been tampered with, that is fairly safe. But you may want to say, well, that's a problem. What if I want to sign my own operating system? The whole UEFI has been designed such that if you want to, you don't have to, but if you want to, you can actually add your own certificate and key information to the BIOS. there is a machine owner key list and mechanism that reuse the shim from, for example, Red Hat, which allow the reuse of user keys. So you can then, you don't have to use for example, the grub 2 from Red Hat. You can decide, I want to use my own grub bootloader, and I want to build and sign my own kernel. I want to sign my own driver with my own key. So all this is possible. It's just, you have the flexibility. Ever you do nothing and you use what's already in there, the Microsoft key, because many companies actually just get their either BIOS extension or driver operating system signed by Microsoft, such that you don't need to do anything. You can just install, enable secure boot in the BIOS, and that's it. Or you may want to deal with yourself a little bit of more complexity, have your own key, and boot your own signed operating system. That is possible. If you do that, you have to take into account a few things, because it may not be possible for you to have all the BIOS extension that you need, depending on the external equipment you're using. So we have created application notes that basically detail the process for you. For example, if you want to create your own EFI application, we have an application that describes how you can do that and sign it with Secure Boot. Sign it so that you can use it with Secure Boot. And the same is true if you want to sign your own version of Linux. We have written step-by-step application describing how to do that. So that was a very quick video on Secure Boot. Thank you for your time. Bye for now.